Yes,
Yes.
sir.
Yes. Okay, so now let us start with the fractional factorial designs and Plackett Burman designs.
રમેશ
Normally, yes.
આ જો લેન્ડસ્કેપમાં હશે ને તો થોડું ફૂલ સ્ક્રીન થશે એકચ્યુઅલી
ઓકે,
લેપટોપમાં હા
જોઈ લઉં છું. એટલે એમાં એવું છે સર, મારે ત્યાં આજે પાવર કટ છે,
હા હા મને બરાબર એવું લાગ્યું
એટલે આજે મોબાઈલમાંથી ભણાવું છું.
રેડી રેડી
મારું
મને લાગ્યું આમ.
પીસી
એટલે
પીસી ચાલુ નથી થઈ.
પછી
અને
રેકોર્ડિંગમાં કેવી રીતે આવે એ હજુ મને ખ્યાલ નથી કે એમાં તમારી સ્ક્રીન હશે ને એ જ આવશે પાછું
ઓકે, પણ હું લેન્ડસ્કેપ કરું છું તો આખું
નથી
બધું
આવતું વિઝિબલ
નથી
નથી
આવતું.
નહીં
નથી
નહીં
આવતું સ્ક્રીન.
કઈ વાંધો નહીં કન્ટિન્યુ
હા
કરો
સર.
ચાલશે નો પ્રોબ્લેમ
હા સર. એ કંઈક ડિવાઇસનો જ પ્રોબ્લેમ છે. સો sorry for the inconvenience today. Let us continue with the fractional factorial designs and Plackett Burman designs. Now, when sometimes the number of factors affecting our very response are very very high, it is not possible to perform the experiments at all the possible combinations because the number of experimental runs will increase drastically. Let us give an example. If we have two factors, we need to perform four experiments if we are working only at two levels. If we have three factors, we need to perform 8 experiments. If we have four factors, we need to perform 16 experiments. If we have five, we need to perform 32 experiments. If we have six, we require 64 experiments. If we have seven factors, we require 128 experiments, and so on. So, as the number of factors increases, the number of experimental runs required increases drastically. Okay, if you look at the three level designs, it will be more drastic than this. If we have two factor three level design, we need to perform 9 experiments. If we have three factor three level design, we need to perform 27 experiments. If we have four factor three level design, we need to perform 81 experiments. Okay, so only using four factors we need to perform 81 experiments if we are working at three levels. So the alternative to this problem is either fractional factorial designs or Plackett Burman designs. So let us start with the fractional factorial design first. As the name says, they are fraction of a full factorial design. Okay, they are nothing but a fraction of full factorial design. So we are performing experiments at a fraction, at a small portion of the full factorial design. Now they are normally represented by L, that is level raised to factor minus k, where k is the fraction. If we are working with the half fraction, then k will be 1. If we are working with the 1/4 fraction, the k will be 2, and so on. So k is fraction. So for example, if I have a two level 6 factor design and I want to work with the half the fraction, so it will be represented as 2 raised to 6 minus 1. If I have two factors, so two levels 4 factors, so it will be represented as 2 raised to 4 minus 1, and the experimental runs required will be equivalent to 2 raised to 4 minus 1, that is 2 raised to 3, that is 8 only. Over here 2 raised to 5, that is 32 only. Now how to design a three factor two level fractional factorial design. So normally there are two techniques, two methods by which we can design a fractional factorial design. First one, that is to construct a 2 raised to 2 full factorial design, and then x3 is equal to x1 into x2. So we can get the two level three factor fractional factorial design. Otherwise we need to perform 8 experiments. If we are working with the three factors, we need to perform 8 experiments. Okay, over here we can work only with the 4 experiments, but at the cost of the interaction term, because x3 is equivalent to x1 into x2, so we will not get any idea about the x3, so x1 x2. Okay, then design of 4 factor 2 level, again that can also be constructed in the similar way. X4, that is equivalent to x1 multiplied by x2 multiplied by x3. Okay, so this is the one way one method of constructing a fractional factorial design. Then a 6 factor 2 level fractional factorial design. So 2 raised to 6 minus 3. Here x4 will be equivalent to x1 x2, x5 will be equivalent to x2 x3, and x6 will be equivalent to x1 x3, x2 x3. Okay, reading it. So by this we can construct a fractional factorial design. Another way of constructing a fractional factorial design is by using the blocking. We have not discussed blocking in detail, so let me explain the blocking in detail. One minute. Within a while, I'll share another device, my laptop. So wait for a while. Students, please wait for 2 or 5 minutes. Okay, I'll connect my PC and then I'll share my presentation from the PC. Meanwhile, if you have any questions, any queries, you can ask. 1 minute. There is some problem with the sharing, I think. Chintan sir, please share something so that I can
Ah,
share.
hello sir.
I think there is issue with sharing.
1 minute sir. સર એવું રીતે તમે રીજોઈન કરો ફરીથી.
એવું છે? ઓકે સર.
હા એવું કરો, ટ્રાય કરું.
Okay, so my
ઓકે.
presentation is now visible. Okay, we have discussed the how fractional factorial designs work. Now let me show you another way how to construct the experimental designs, fractional factorial designs using an MS Excel workbook. Okay. So first thing we need to construct. For an example, if I'm willing to construct a two-level four-factor fractional factorial design. So first I need to construct a three fact three factor two level full factorial design using the rule. First variable changes its value every experiment. Second variable changes its value every two experiments, that is number of levels. And third variable changes its value every four experiments, that is level square. So this is a standard experimental design. Now another way to construct the design is for or how to reduce I'll prepare a complete design, not half one. 1 minute. That is with 16 experimental runs. Okay, and this variable changes its value every 8 experiments. Okay, now I will find out the overall interaction, that is x1 multiplied by x2 multiplied by x3, x1, x2, x3, x4. So that is equivalent to x1 multiplied by x2 multiplied by x3 multiplied by x4. Okay, and I'll find out the values of each, either it will be plus 1 or minus 1, and then I will sort them according to the values. So these experiments are having the value of x4 as minus 1. These experiments are having the value of x4 as plus 1. Okay. Now, when we are performing the experiments, at that time also we can use the same method, and that is called blocking. Out of this total experiments, which are to be performed on which day, that is called blocking. Let me 1 minute show you the standard run so that you can better understand. 1 minute. So this is a standard order. I don't care. Now, if we change them according to this order now changed. Okay, if you look at this 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, etc. etc. So half the experiments are on the first half, the rest half are in the second half. And if you look at the levels of each factor closely, you can find that each factor assumes -1 level value 4 times and +1 value 4 times. Let me color them differently. So the +1 are marked with green in yellow region only, and -1 I am marking with the yellow itself. Can you observe that your each factor from the first half, rest half, let me change the color so it is not confusing with the rest of the things. Okay, in first half, each variable is assuming -1 value 4 times, +1 value 4 times. And so, if there is change in any of the uncontrollable variable, it will be equally distributed amongst all the factors. When I am performing this first 8 experiments on day 1, it will be equally distributed among the rest of the factor, all the four factors. In second half also, each variable assumes the -1 value 4 times and +1 value 4 times. Let me color -1 with the blue so that you can understand. So each factor, it's assuming -1 value 4 times and +1 value 4 times. So they are equally distributed, and hence the change because of the uncontrollable variables will be equally distributed among all the observations. Getting it? So this is called blocking. This is my first block, the yellow one, and the orange one is my second block. So I will perform first 8 experiments which are marked with the yellow on day 1, and second 8 experiments which are marked with the orange on day 2. So this is called blocking. The same blocking can also be utilized for reducing the number of experiments to construct a fractional factorial design. So here I will perform the experiments only using those variables which are marked with the +1. So this 8 experiments I will perform. Okay, rest I will not perform. So this is my new design now using the x1, x2, x3 and x4. So this is my fractional factorial design. Those experiments which are marked with 1, that is they are having value 1, that I am performing. So these are my 4 experimental variables and 8 experimental runs. Now what problem arises over here? That is critical. That is I need to explain, and the term is called confounding. The literal meaning of confounding is confusing. When it is not possible for us to differentiate between the effect of 2 or more factors, that is called confounding or confusing. Let me explain how the confounding takes place. So interaction terms we need to study. So x1 x2, x1 x3, then x2 x3, and x1 x4, x2 x4, x3, x4. Say these are the interaction terms. Now x1, x2 that is equal to x1 multiplied by x2. Then x1, x3 is equal to x1 multiplied by x3. x2, x3 is equal to x2 multiplied by x3. x1, x4 that is equivalent to x1 multiplied by x4. Similarly, rest of the values there. Now, if I drag these values, and let me clear formats from here so that it will be easier for you to understand. Okay, now if you look at these lines, you will find that the line of x1, x2 is exactly similar to that of the x3, x4. Okay, getting it? Similarly, the column of x1, x3 is exactly equivalent, similar to that of the x2, x4. And line of x2, x3 and x1, x4 are also equally similar. Okay, so now we cannot differentiate when we are calculating the y, okay, the coefficient. What we need to do is we need to multiply it with the x1, x2, x1, x3, x2, x3, etc., etc. So, in order to determine the coefficients b1, b2, b3, b4, b12, 13, b23, etc., etc., we will get the same value of b12 and b14. We will get same value for b13 and b24 and b23 and b14. So, we cannot differentiate between these two, and hence this phenomena is called confounding, as it is confusing. So in a fractional factorial design, we must compromise with the interaction terms. We are not getting proper idea about the interaction terms. So that is called confounding, and that is the limitation of the fractional factorial designs. So in your MCQ, this may be the question that confounding is a limitation of which of the factorial design. So the answer is fractional factorial design. Or which of the following terminology is commonly observed in fractional factorial design, and they may provide you with the terminologies like interaction, non-linearity, confounding, etc., etc. And you need to answer that confounding is the correct one. Clear? Getting it? Or any question?
No, sir, clear.
No, sir.
Okay, good. So let us move ahead with the Plackett and Burman designs. You have properly understood the fractional factorial designs, I assume, and that's why I'm moving ahead with the Plackett Burman designs. Okay, Plackett Burman designs. These designs are the true form of the screening designs. When we have more number of variables and we want to screen them, that is, which variables are to be included in the experimentation and which are to be omitted, or that are kept to be kept constant. That is to be assessed by Plackett and Burman designs. That is done by proper screening. So these designs have experimental runs always in the multiple of 4. Mind well, these designs have experimental runs always in the multiple of 4. So either 4, 8, 12, 16, 20, 24 experiments are there. Then we can study maximum n minus 1 factor, where n is the number of experiments to be performed. So using 4 number of experiments, we can analyze maximum 3 factors. Using 8 experiments, we can analyze 4, 5, 6, 7 or 8 experiments. 6 or 7 experiments. Using 12 experiments, we can analyze either 7, 8, 9 or 10 or 11 up to maximum 11 factors and so on. Getting it?
Yes, sir.
Two things you need to remember. First one, the experimental runs are always in the multiple of 4. And second thing, we can analyze maximum n minus 1 variables. Okay. Now, here the combination of plus and minus signs for the construction of design is given over here. For n is equal to 4, it is plus 1 minus 1. For n is equal to 8, it is plus 1 minus 1 plus 1 minus 1 minus 1 and so on. Now, if you look at the question, you will find that the plus and minus signs are totally random and you will not observe any repeating pattern. So you need to take care. You will not observe any repeating pattern. Second thing is, here only 3 signs are given for 4 experiments. 7 signs are given for 8 experiments. 11 for 12 and so on. So one less symbol, one less sign is given. This is nothing but the first line configuration. It is called first line configuration. And using this configuration, you need to construct the entire design. Here, only 3 are given for 4, 7 for 8 runs. Because the last experiment is always performed using minus 1 level for all the variables. Last experiment is performed using minus 1 level of all the variables. And hence, if you observe this series carefully, you will find that in all the experiments, plus 1 sign is 1 times more than that of the minus 1 sign. Okay, in n is equal to 4, if you find that the 1 minute plus 1 is 2 times and minus 1 is only once. Here plus 1 is 4 times and minus 1 is only thrice. Plus 1 is over here 6 times and minus 1 is 5 times. So minus 1 sign will be 1 times lesser than that of the plus 1 sign. So you need not to mug up this series. You can construct this series by your own. But just remember 2 rules. First rule, plus 1 sign will be 1 times more than that of the minus 1 sign. And second thing is, there should not be any repeating pattern. There should not be any repeating pattern. કોઈ પણ જગ્યાએ કોઈ પણ pattern repeat ના થાય. If you look carefully for n is equal to 20, you will find that plus 2, plus 1, minus 1, minus 1. Then again plus 1 and 1 times minus 1. Then plus 1, then minus 1. Then plus 1, then minus 1. Plus 1, then minus 1, 3 times, 4 times. Then plus and minus. So you will not find any repeating pattern. If repeating pattern is observed, then there are chances that 2 or more columns may be identical to each other. And hence, confounding may be observed over here as well. So to avoid confounding, you should avoid repeating patterns. Clear? Now let me explain how to construct the design. So to construct the Plackett and Burman design, here I have constructed using 11 factors, that is 12 experimental runs. So the first cell configuration, first line configuration which is provided, which I have kept over 1 minute, that is placed in the cell of x1. Okay, this is the first line configuration which is given over in the book for first line. So I have written the pattern as it is. 12 માટે છે plus 1 minus 1 plus 1 plus 1 minus 1 minus 1 minus 1. So I have written as such. It is okay. Plus 1 minus 1 plus 1 plus 1 minus 1 minus 1 minus 1 plus 1 and minus 1. As such, I have written in a column. Now, don't write the last column while constructing the design. This is always to be written at the end. Okay. This you should not write at initial stage while constructing the design. Okay, you assume that it is not present at the time of the construction of the design. Now, what you need to do is you need to shift the last sign of the first factor x1 to the first place over here, and rest of the signs will move downwards. Similarly, for constructing x3, just place this plus 1 at the top place, rest will move downwards, and so on. So you need to repeat the same thing. Clear?
Clear, sir.
Good. Now, if you observe the patterns diagonally, you will find that all the signs in are equal. They are similar. Okay. If you this is the way to verify. At least 2 or 3 times you need to verify. You need to check whether all these signs in a diagonal are equal or not. If there is some conspiracy, some mistake, you can correct it. Getting it?
Yes, sir.
Nice. And at the last, you need to place the last values, that is -1 in all the factors. -1 in all the factors. So by this, you can construct a center composite design using the first line string provided in the books, or you can construct your own string as well. That is not an issue. But just you need to remember that no repeating pattern, and plus 1 times more than that of the -1. Clear?
Yes, sir.
Good. So with this, we are ending today's session. If you have any question, any query, you can ask.
સર આ એફએફડી અને પીબીડી માંથી ફાર્માસ્યુટિકલ ફિલ્ડમાં મોસ્ટ વાઇડલી કઈ યુઝ થાય છે?
પ્લેકેટ બર્મન વધારે યુઝ થાય છે, કારણ કે એ સ્ક્રીનિંગ માટે યુઝ થશે. ધેટ્સ વાય નોર્મલી વી યુઝ પ્લેકેટ બર્મન ડિઝાઇન. ફ્રેક્શનલ ફેક્ટોરિયલ ડિઝાઇન્સની ઘણી બધી લિમિટેશન્સ છે. વન ઓફ ધેમ ઇઝ કન્ફાઉન્ડિંગ. Second is we are not getting the idea about the interaction terms, and normally we don't use fractional factorial designs. Plackett Burman design is most commonly used for screening. When we have more number of factors, we can screen them, and after analyzing the design, we can find out which factors are affecting the response more prominently, and those factors are only to be analyzed. For this analysis, one chart is there, that is Pareto chart. Okay, that you need to prepare, and that Pareto chart will provide you the idea which factors are to be studied for further. That is, which factors are to be selected for further study. That the Pareto chart will provide a cutoff value out of the n number of factors. You need to input that how many factors you want to analyze, and the Pareto chart will provide the idea that this factor